Hey everyone, welcome to the very last video in the series on chapter 10 reactions. Okay, so up to this point, we've been worrying about like Grignard reagents, organolithium reagents, Gilman reagents. We've been worried about different kinds of reagents. Okay, in this video, we're not going to be worried about any specific kind of reagents. Okay, so there's no like specific reagent we're going to be worried about. We're just going to be worried about turning carbonyl groups into alcohols. Okay, so this is going to be reduction of carbonyls. Okay, so reduction of carbonyl groups. Okay, so there's two ways to do reduction of carbonyls. Okay, so we're going to talk about these two ways, and then I'm going to do one mechanism, and then we'll call it there. All right, so one way is sodium borohydride, or NaBH4. The other way is lithium aluminum hydride, or LAH, okay, or lithium aluminum hydride, right? So this is sometimes referred to as LAH, okay? Okay, so I think these reactions are fairly simple. I don't think there's a lot to these. So what all that's happening is I'm taking a carbonyl group, so a ketone or an aldehyde or an ester or a acid chloride or a carboxyl, right? And I'm throwing in NaBH4. And what this does is it turns the carbonyl group into an alcohol. That's it. Okay. It really is that simple. Okay. So all I have to do is just take this carbonyl, turn it into an alcohol. Okay. That's all it does. So this is reduction of carbonyl groups. Okay. Again, aldehydes are going to do the same thing. So this is with a ketone. Ketones make a 2-degree alcohol. With an aldehyde, so I'll take some aldehyde here, and then I react this with NaBH4. What this is going to do is it's going to make a primary alcohol, right? So aldehydes make primary alcohols and ketones make secondary alcohols. Yeah. The final thing that I can reduce with NaBH4 is an acid chloride. All right. So if I take an acid chloride like this one and I put in NaBH4, then what happens is I get a primary alcohol. So the carbonyl turns into an alcohol and chlorine leaves. So I get a primary alcohol again. All right. That's it. Okay. So NaBH4, this one works with ketones, aldehydes, and acid chlorides. Okay. It does not work with esters or carboxyl groups. Okay. Lithium aluminum hydride, on the other hand, this one works with ketones, aldehydes, acid chlorides, esters, and whoa now, and carboxyls. Okay. So again, if I would take any of these first three, so and put in first step lithium aluminum hydride, second step H3O plus, then I'm going to get alcohol, bad handwriting, alcohol. Same thing here, right? If I would get this, then it's also going to turn into an alcohol. And then finally, it is also going to work with this acid chloride, right? So it works with all of these. All right, lithium aluminum hydride works with all of these. Sodium borohydride does not work with esters and carboxyl groups because sodium borohydride is a weak reducing agent. Okay, so sodium borohydride is weak. Lithium aluminum hydride is strong. Okay, so that's definitely important to remember. Okay, definitely important to remember. Okay, so now if I have an ester, right? So we'll take some ester like, oh, I don't know, this ester with lithium aluminum hydride. With sodium borohydride, it wouldn't work, right? So we'll take it with lithium aluminum hydride and then throw in some acid. Then what's going to happen is the carbonyl group turns into an OH, and this group right here leaves. So I'm just left with a primary alcohol. So esters and esters, aldehydes, and acid chlorides all become primary alcohols, right? All these become primary alcohols. Same thing with carboxyl groups, right? So if I have some carboxyl groups, so let's say I have this carboxyl group, this carboxyl anion, okay? So this has a negative charge, all right? I need to put it in with the negative charge because it can cause problems whenever it is in its acidic form. Okay, so it's usually in like this, but that's a carboxy group, right? This is also going to get reduced into a primary alcohol. So again, this O just leaves, and then I just have this turning into an alcohol. Okay, so that's it. Okay, so now let's look at some comparisons between these two because I think that's important to make these distinctions. So let's look at a molecule like this. So this molecule has a ketone over here, and it has an ester over here. So now if I put this through NABH4, NABH4 is weak, right? So NABH4 cannot reduce this ester, but it can reduce this ketone. So what that's going to give me is a secondary alcohol on the left, and then the ester just doesn't do anything, right? The ester just stays the same. So then over here, I get this secondary alcohol, right? Or this, excuse me, that should be a ester. Sorry. I said the ester doesn't do anything. Ester doesn't do anything, right? Okay. Conversely, if I take this very same thing and I use lithium aluminum hydride instead, then what happens is lithium aluminum hydride can reduce this ester, and it can also reduce this ketone. So both of these are going to get reduced. Both of these are going to get reduced. So I have primary alcohol and a secondary alcohol in this molecule now, okay? So these are the distinctions that I had to make between these two molecules, or these two reducing agents, okay? All right, so I just wanted to be clear about making this distinction, and then there's one other reducing agent that I kind of want to talk about. So let me erase this, and then we'll talk about this other reducing agent. This other reducing agent is weak, but there's something special about it that I think makes it important for this. So, okay, the other reducing agent is something called Raney nickel. So Raney nickel is just a special technique of preparing nickel. We don't need to worry about it. But what it does is it gets rid of double bonds. But this works. So this works with ketones, aldehydes, and double/triple bonds. Okay, so lithium aluminum hydride and sodium borohydride do nothing to double and triple bonds, but Raney nickel completely gets rid of them. So let's take a molecule that has a ketone in it, and it also has a double bond in it. All right. So if I put in H2 with Raney nickel, all that happens is the ketone becomes an alcohol, and then the double bond goes away as well. Okay. That's it. All right. Let's take another molecule that has multiple double bonds. We'll say it has double bond here, and it has a double bond here, and then it has an aldehyde. Again, aldehydes can get reduced, no problem. So we'll put in H2 and Raney nickel. And what's going to happen is 1, 2, 3, 4, 5, 6. I get an alcohol here, and then the two double bonds just go away. All right. So that's all that happens. And again, I can also have a triple bond in there as well. Absolutely no problem. This can also get reduced. So then if I put this in with H2 and Raney nickel, it has no problem reducing this. This is 1, 2, 3, 4, 5 carbons. And all that's going to happen is this ketone becomes a secondary alcohol and the triple bond goes away. All right. So that's it. So Raney nickel is very simple. The only difference is that Raney nickel can also, it's similar to sodium borohydride, but it can also get rid of double and triple bonds. Okay. Alrighty. So we'll talk about one mechanism, and then we'll be done. So the mechanism for sodium borohydride and lithium aluminum hydride is the same. Okay, it's the same. So let's look at the mechanism of sodium borohydride with acetone. And I lied, we're actually going to look at two mechanisms, sorry. So this just becomes a secondary alcohol, right? So now let's take a look at the mechanism. Fairly straightforward, all right, fairly straightforward. So sodium borohydride looks like this. So it's Na plus, and then B with 4 H's on it. Let me write this a different way, sorry. So it's B with boron with 4 H's on it. This has a negative charge, and then there's a sodium counterion there as well. So one of these hydrogens is going to go over here and act as a nucleophile on this carbonyl group and push a lone pair up there. All right. And then so what that's going to give me is it's going to give me this alkoxide, right? And I just added a hydrogen on here, right? And so this sodium is here as well. And so now, usually this is dissolved in some kind of alcohol or water or something, right? So we'll say water is in there. So water can come in and get deprotonated in order to protonate this alkoxide. Okay, so water gets deprotonated, and then that's going to give me OH. And then in this case, I also made NaOH. Okay, so this is the mechanism for NaBH4. All right, nothing too crazy. All right, so in this case, the hydrogen is just acting as a nucleophile. All right, just acting as a nucleophile. Okay, so let's do the mechanism of an ester now with, and this is esters and acid chlorides are going to have the same reaction pathway with lithium aluminum hydride. Okay, so we'll move down a little bit so we have a little bit more room. And so all this is going to do is this is just going to give me a primary alcohol. All right. So let's look at why. So again, I'm going to be starting off with this. Okay. And lithium aluminum hydride is just an aluminum molecule or aluminum atom bonded to 4 hydrogens. And this has a negative charge, and then lithium is there as a counterion. One of these hydrogens, just like last time, is going to go up here and attack this carbon, and those electrons are going to go onto the oxygen. So then I get this alkoxide, right? And then I get a lithium as well. I also get AlH3, and up here I also got BH3, but I'm not too worried about that. But technically here I get BH3, and technically here, right, I get AlH3, but not a huge concern. But just for atom economy, I guess we'll do it. Anyway, so now, just like with the reactions of Grignards and organolithiums with esters and acid chlorides, this is going to reform this carbonyl group, and then this is going to leave. Okay. So what that means is that I'm going to now get a ketone. Or excuse me, not a ketone. I'm sorry. I'm going to get an aldehyde. Okay. So I get this aldehyde. And I also get, as a byproduct, I get lithium with this alkoxide. And that's it. Okay. Okay. So now another lithium aluminum hydride is going to come in. And what that's going to do is it's just going to add another hydrogen on there, and those electrons are going to go onto this oxygen, just like last time. And now I've made this primary alkoxide. Okay. All right, because now I have 2 hydrogens here, right? I have 2 hydrogens on that carbon where I've drawn those 2 bonds. And I also get AlH3. So now, whenever I throw the acid in there, so my H3O plus, all that's going to happen is H3O plus is going to get deprotonated. And then that is going to give me my very final product, which is going to be this primary alcohol that we drew over there. And then I also get water. That's it. So this is the mechanism of sodium borohydride and lithium aluminum hydride and everything that happens there. Okay. And then as a last thing, we also have this lithium here as a counterion, right? So lithium is there as a counterion. But that's it. So this is my mechanism for this. So like I said, this is the last video for chapter 10. So hopefully you stuck with me. If you did, I really appreciate you sticking with me for all these videos. Hopefully they're helpful. I really do hope that they are. And after this, we're going to be starting reactions of chapter 11. All right. So, use these videos, study up, happy studying, and I guess I'll see you in chapter 11.